All right, welcome back to Burt's Basics. Today we embark on the lovely world of chemistry. Now, I know some of you are going to be in this medical anatomy class and never have taken a chemistry class, so this is going to be the basic introduction to an atom, a little bit on using the periodic table and knowing some basic terminology. So let's go ahead and get started. Remember, at the end there is a quiz that you guys can check your knowledge and see how well you do. So here we go. Maybe. There we go. So these are the things that you have to know in concepts 1, 2, and 3 of Unit 2. So you can see in Standard 1, we're talking about the basic setup of an atom. Number 2, we're talking about what ingredients in the periodic table make up who we are. And Standard 3 is some chemistry words about difference between compound and molecule. So let's start with our basics of a atom. So this is your basic structure of an atom. Remember, I'm going to teach this like you've never seen it before. So if you have had chemistry, just kind of bear with me for a second. The center of every atom is a thing called a nucleus. Now, in the nucleus, there are two major particles. They call them subatomic particles because remember, sub means below. And so these are smaller than an atom. And these guys are the ones in green and red. If you're colorblind, I am sorry. The green ones are neutrons. Now, if you notice, these green bubbles have no charge in them. Okay, they're blank. Neutrons are neutral. They have no charge, and their main job is to stabilize the nucleus. So if we look at our protons here, the protons are the orange ones, and they are positive. If you ever taken two magnets that have the same charge and put them side by side with each other, they repel each other. So the whole goal of the neutron is to stick its wiggly fingers in there and separate the positives so it can help stabilize the nucleus. Unfortunately, the nucleus gets larger and larger and larger, and sooner or later, no matter how hard those neutrons try, those protons are going to not be able to be together, and they're going to fall apart, which starts at element 83, which is bismuth, and that's what we call radioactive. So our whole goal of the neutrons is to stabilize the nucleus. So now let's talk about protons, then we'll come back to electrons. When we talk about protons, protons account for one of the two numbers you're going to see on the periodic table. So every periodic table has two numbers. Now I'm never going to say top and I'm never going to say bottom because they flip sometimes. So you got to make sure that you're always looking at the correct one. So I'm always going to say the smaller number and the larger number. And on our class, we're always going to round. Okay. Once we talk about isotopes, we'll talk about why there's a decimal there. But to truly understand the decimal, you have to understand the word isotopes, which is not this video. So let's go ahead and start with the smaller of the two numbers, which is called the atomic number. The atomic number represents the number of protons. So in this case, potassium has 19 protons. So if I look at a periodic table, you can see here that there's boron, and they always have two numbers. They have a larger one and a smaller one. The smaller one is always the number of protons. So boron has 5 protons. Carbon has 6 protons. Nitrogen has 7 protons. Oxygen has 8, and so on and so on and so on. Now here's the kicker. That is super fun. I'm going to put myself right above this family. There we go. If I ask you, tell me everything about an atom that has 6 protons, in most classes people are going to be like, oh, that's carbon. And I would slap them. Okay? If you have 6 protons, it tells you so much things you need to know about it. It tells you that, number one, if I have 6 protons at standard temperature and pressure, I'm always a solid. I'm always black in color. I am brittle. If you hit me with a hammer, I'll fall apart. Number 6 tells you that you are the element carbon. Now, you guys are more familiar with carbon in your pencil lead. It's not lead, by the way. Your graphite in your pencil is carbon. Okay, so that's what carbon looks like. So if I could take a nucleus of carbon, which is a black, solid, brittle, and I could take one more proton, and I just shove it in the nucleus, all of a sudden I go from 6 protons to 7 protons. Once I go to 7 protons, check it out. Now I'm nitrogen. And I am telling you, if I have 7 protons, I'm now a gas. If I have 7 protons, I'm now odorless. If I have 7 protons, I'm colorless. If I have 7 protons, I make up 3/4 of this room, because that's what our atmosphere mostly is. The protons tell you what physical properties the element has. So you're telling me if I have a black solid and I put in 1 proton, I go to a colorless, odorless gas? Yes, that's why chemistry is so freaking rad, okay? The protons tell you the physical properties of an atom, and the way we always tell the protons is we look at let's move myself again, the atomic number, okay? Now, the atomic mass is different. The atomic mass is the sum of the nucleus. So if we look at my nucleus, there's 2 things in it. It's my protons and my neutrons. So that means in my nucleus, I have 39 particles. Remember, we're always going to round. Well, if 19 of them are protons, you subtract big from little, that gives you the number of neutrons. In this case, there are 20 neutrons in the potassium nucleus. Now, if you notice, electrons are kind of feeling left out here. Electrons are going to be in more of a different lesson because they are responsible for one thing only. If we look at them, they float around on these guys right here. These guys go by many names. They go by rings or clouds or orbits, but they're not in the nucleus. They're on the outside of the nucleus, and they are negatively charged. But they are pulled towards the nucleus, so they like to stay nice and close, right? They want to be close. They don't float off into space. So these electrons are responsible for one thing only. If I have another atom come on the screen, here he comes, bloop, 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 and I have another atom come on the screen, bloop, 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 bloop. If they hit each other, the first thing that's going to hit is not the nucleus, right? The nucleus is in the center. The first thing that's going to hit is these outside shells, and that's what electrons are responsible for. They're responsible for bonding, which in the next video we're going to talk about ionic and covalent and ions and electrolytes. That's all about how the electrons change, steal, move in this world to become stable. And that's what electrons are for. So when we talk about electrons, their responsibility is chemical properties, how well they're going to bond. When we talk about protons, they're responsible as physical properties, melting point, boiling point, brittle, malleable. When we talk about neutrons, their job is a peacemaker, to try to make it as neutral as possible. You can find out all this information by looking at a basic periodic table. On the periodic table, every element is neutral. Okay, I hope that sentence makes sense. So if I have 19 pluses and I'm neutral, which means I have a charge of 0. If I have 19 pluses, I have 19 minuses. So for basic chemistry, you can use this atomic number for both the number of protons and the number of neutrons, number of protons and the number of electrons. But you got to be careful, because when we start talking chemistry, we're going to start moving electrons around, and then that number won't be accurate anymore. So those are your basic chemistry. Now let's look at the human body really quick. This is your human body. If you notice, he is not wearing socks. Or actually, he is wearing socks, and apparently nothing else. Sorry, this is a PG rating video. But if you look, 65% of the body is oxygen, 18 carbon, 10 hydrogen, and 3 nitrogen. Calcium's next on the list, and then there's a lot of others. So most of the time when we talk about anatomy, there are 4 elements that make up the majority of my body, and that is the almighty Chon. Okay, when I think of Chon, I think of a person, Chon. Okay, yes, that's Johnny Bravo, but that's okay. I think of Chon, carbon, hydrogen, oxygen, nitrogen. Now, just to let you know, I'm going to try to confuse you. I'm going to say true or false. Calcium, hydrogen, oxygen, nitrogen make up the majority part of the body, because people see calcium, they're like, oh, that starts with a C. Just be careful. On a periodic table, calcium is Ca, where carbon is C. Know the 4 major elements that make up your body, which is Chon. The last thing on the things you need to know is molecules versus compounds. Now, this is more of an advanced AP concept, but I'm just going to go with it anyway. Simple version of these two. If you are the same element, so you can see here, 2 hydrogens, 2 oxygens, 2 nitrogens, 2 chlorines. If you've taken chemistry, these are called your diatomics, okay? If you're the same element, you are generally classified as a molecule, okay? Molecule is 2 or more elements that are exactly the same. If you're 2 elements that are different, you are generally referred to as a compound. So compound of water, compound of nitrogen dioxide, compound of carbon dioxide, molecular chlorine, molecular nitrogen. That's it in a nutshell. Now, when you get to advanced placement, it also has to deal with the type of bonds they make. So almost all molecules have covalent bonds, where compounds can have ionic and sometimes covalent as well. So it just kind of depends on the bonds that are made. But those are the difference between them. Now, you have now finished the basics of chemistry. Let's go ahead and do a test to see how good you are. So let me move my face. So what I'd like you to do is really try on this one. Pause it here, answer all of these questions, and then on the next page is the answer key, and I hope you get 100%. Thank you for watching Burt's Basics, and I'm going to the answer key now. Enjoy.